So if we're revolving around the y-axis, the surface area formula, this is surface area, not volume, right? The surface area formula would be some function in terms of y. So we got to rewrite this function that we're revolving in terms of y. And then we multiply it by the square root of 1 minus the derivative of y squared. And so that square root part is usually what makes these integrals not work. We have to use some sort of numerical method to get it. Okay. So to get this in terms of y, I divide 4 from both sides. Then I use a fourth root to finish getting x by itself. Sorry about the terrible handwriting there. So that's our g of y. And then limits of integration. If you plug in 0 in for x, you get y equals 0. And if you plug in 1 in for x, you get y equals 4. So those are the lowest and highest values. So we get 2 times pi times the fourth root of y over 4 times the square root of 1 minus the derivative of y, of the function of y, I should say. So the 1/4, here, this is a 1/4 power. So if I take a derivative, the 1/4 comes down. It's y over 4 to the negative 3/4, because 1/4 subtracted by 1 makes negative 3/4. And then we multiply by the derivative of the innermost function because of the chain rule. There's our derivative. That's 1/16. And then there's a way we could make this neater. Because if it's negative 3/4, you could move that to the denominator and you have y over 4 to the 3/4 power. So I think the easiest way to do that would be to say y over 4 times the 4, and then in the numerator, the fourth root of y fourths. Let me just double check. Because this is something to the 1/4 power, and this is something to the first power. So 1/4 minus 1 makes negative 3/4, just like it's supposed to. And then this is still the fourth root. And then down here, 16 times y over 4, that makes 4y. Okay, so I rewrote it a bunch. I don't even know if it's going to matter because I don't know if I can take this derivative, but I can take this antiderivative. But this is the fourth root of y over 4 over 4y. And that's supposed to be squared, dy. So I'm going to factor out that 2 pi. I'm going to rewrite a little bit to see if I can integrate without using a calculator. It's hideous, isn't it? Squaring, this is a fourth root, so now that's a square root because 1/4 times 2 makes 1/2 for power. I don't think there's, I'm going to go check with a calculator. I don't think there's any way of integrating this by hand. I put it through an integral calculator and I couldn't get any algebraic way of rewriting and then integrating. So, yeah, so that's what this part up here says. If you cannot evaluate the integral exactly, use your calculator to approximate it. So you won't have anything like this on the final.